Hey, what's up, guys? So in this very short video, that I want to talk about the implication of the BPP if SAMP is a subset of BPP. Okay, so right, so in the standard right, so I guess the golden rule, right, the golden rule in the computer science, computer complexity, right, because in the computational complexity, since we cannot prove P equals NP, right, so almost that we cannot prove anything like unconditionally, so there's a golden rule that the pH never collapses. So this is a golden rule that we believe that pH will not never collapses. So P equals NP will be the P do not the same as NP will be just the zero level, but we believe that they're all different. Also, if we want to say that I want to prove that something is unlikely to happen, then we will want to show that if something happened, then pH collapses. Okay, so the tool is basically if you want to if we want to prove that something is unlikely to happen, I think that this is also like related to those similar quantum computing. If something is unlikely to happen, you want to show that if this happened, if this is true, then pH collapses. In some level. Okay. Okay, so the very simple one is just that if P equals to NP, then pH collapses. pH collapses, and everything will become P. Okay, so I think this should be zero level or something. Should be like zero level. Okay, the second one also famous is that if factoring, right? If factoring is NP complete, and you can show that factoring is NP also in co-NP, right? So if factoring is NP complete, then factoring is also NP and co-NP complete. Then you will say that NP equals to co-NP. Then this will collapse into the first level. Okay, because the NP equals to co-NP, which is unlikely to happen. Okay, and there are more. Okay, there are a lot of them. Okay. But in this video, I want to show that another example, which is the if NP is BPP, NP is a subset of BPP. Suppose that you end randomize, right, and then that randomize will give you the powerful tool that you can solve this NP or the NP complete problem. Then this will force also pH collapses into second level. Okay, so the proof tool is basically using the using this comma MA is for most P, and the AM is for most random bits. There is the merlin message, and the sigma 2 is easy for all P for all this P. Okay, then using this AM is MA is supposed to AM, and all this inclusion. Let's say AM is in the pi 2 and MA is in sigma 2. Use this or the Arthur merlin protocol, then you will able to show this. Okay, so if you haven't seen my previous video, that you can check out this the link below that I post. Okay, and the idea is, I guess the idea is the following. So, all right, so we want to okay, so I want to show that if NP is a subset of BPP, then pH collapse. So, so what should we do? Okay, so let's say we take sigma 2. We take L belongs to sigma 2. Right, so sigma 2 is basically for all exists for all P, right? And since NP is a subset of BPP, right? So BPP is also in MA in the AM. But the BPP is the complement to itself, right? So let me say co-NP is also in the BPP. Okay, so I can replace this for all P, right? This is for this is co-NP part, right? This is co-NP part. I can replace this co-NP part to the what? To the let's say BPP, right? So BPP. So I have for most, I have the BP. Okay, so is this the BP? Means is this a message that the author can run the probabilistic? So this will force this guy to be should be subset MA. Okay, also subset of A. Okay, and okay, so this first one. Now I take pi 2. I take pi 2, right? So now I take pi 2. So pi 2 is what? Pi 2 is that for all exist p. Okay, and exist p is also in the BPP. Right, because I assume NP is a subset of BPP. So this means that I can write for all. I can solve this exist p using the most p. But what? But this means that but this means that exist p I can use p. Okay. Okay. So now this is so if I write here, then I would say that this is b exist p. Okay. Oh, I think the proof idea should be here. Okay. If I keep doing this line, then I get b exist p, right? Because AM by definition is the foremost. There is the exist a message that merlin can send. So b exist p. And exist b is NP complete, the NP complete part, right? So I can replace it to be BPP, right? So I can just replace to BPP by my assumption. So this proves that you just concatenation to random coin, right? So it basically was BPP. Okay, so you show that sigma 2 is in. So I think we don't need this. So sigma 2 is a subset of BPP, right? But I know that sigma BPP is unconditionally in the sigma 2 in pi 2, right? But you can prove that this is, but BPP is like conjugate, this complement to itself, right? So this also, if you complement itself, you get pi 2 also in the BPP, subset BPP, also in the sigma 2 intersection pi 2. So you have sigma 2 is in the sigma 2 intersection pi 2, and then pi 2 is also in the sigma 2 in the pi 2. So your force pi 2 equals to sigma 2. Okay, so where pH collapses into second level. Okay, so yeah, so that's it. This is one application of why NP is why people believe, right? I mean, people also believe that NP is also unlikely to be the subset of BP. See you guys next video.